So picking up with making an orderly list as a strategy, this next example says a rectangle has an area of 120 square centimeters. Its length and width are whole numbers. Then it's got two questions. First one, what are the possibilities for the two numbers? Well, when you're dealing with area, it's simply length times width. So the possibilities for the two numbers, I'm looking for two numbers that multiply to equal 120. And these are whole numbers, so we don't need to worry about fractions or anything like that. Don't need to even worry about negatives, which wouldn't make sense when you're dealing with area anyhow. So I'm looking for pairs of numbers that multiply to equal 120, because length times width is 120. So we could have, and you'll see, hopefully you'll see here a little bit of an order to this. You could have 1 and 120. So depending on how you envision that rectangle, it's either super, super long and skinny or super, super tall and skinny. But 1 and 120 could be the length and the width. Or you could have 2 and 60. 2 times 60 is 120. Or 3 and 40. Or 4 and 30. Or 5 and 24. Or you can have 6 and 20. Almost done. You could then have 8 and 15. 7 does not go into 120, which is why I skipped it. For the same reason, you'll skip 9. 9 does not evenly divide into 120, but 10 does. So my last possibility is 10 and 12. 11 does not divide into 120. The next number would be 12. Well, we've already got that accounted for. So these are the 8 different possibilities for the length and width of this rectangle. Part B says, which possibility gives the smallest perimeter? Let me switch colors here. So perimeter is found by adding the distance around your rectangle. So here's your length, here's your width. So perimeter is length plus width plus length plus width. You could also say it's twice the length plus the width. If you want to find the smallest perimeter, that means that you want the sum of the length and the width to be the smallest possible. So the smallest possible sum will give you the smallest possible perimeter. So to find the smallest perimeter, you can just add 1 and 120 would be 121. 2 and 60, 62. 3 and 40, 43. And you keep going. 8 and 15, we're at 23. And then 10 and 12, 22. So the smallest sum is the rectangle with length and width 10 and 12. Smallest sum means smallest perimeter. So smallest perimeter is going to be from this 10 by 12 rectangle. So there we have our orderly list of all the possibilities for length and width from the area. And then again, we're able to use those to find our smallest perimeter. Now, in that case, I did draw a picture of the rectangle. I don't know that you necessarily needed the picture in order to solve that one. Some problems, and we'll get to this last example here, a picture is almost necessary. And I'll explain why here when we look at this one. It says, how many posts does it take to support a straight fence 200 feet long if a post is placed every 20 feet? Most people will automatically go, well, 200 divided by 20, that's super easy. The answer is 10. Most kids are going to say that. The answer is 10. I know how to divide. But that's actually incorrect. The answer is 11. And this is where the picture is really useful. So I'm going to let my dots represent the posts. So it says there is a post every 20 feet. So here's my post, then 20 feet, there's another post. 20 feet, there's another post. 20 feet, there's another post. And you can just continue with this. Hopefully I leave myself enough room until you've gone the full 200 feet. So 1, 2, 3, 4, 5. So I'm halfway there. There we go. That should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. There's my 200 feet. So how many posts does it take? Well, if you can count the dots, which represent the posts, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them, because you have both that starting post and the ending post. So in this case, drawing the picture lets you see it's going to take 11 posts, not the 10 that probably most people would guess just at a first glance.